Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Dwi Sudarno Putra. I'm from UNP, Universitas Negeri Padang, Indonesia. Today, in this big event, please let me present about BLDC motor speed control simulation for electrical vehicle. This article reported by me, my friend Agus Baharudin and Firoj Mulani. An electrical vehicle is a vehicle that uses one or more electrical motors for propulsion. EVs include but are not limited to road and rail vehicle, surface and underwater vessel, electric aircraft, and electric spacecraft. There are a lot of electric machine or motor type used in electrical vehicle. They are AC or induction motor, DC motor, BLDC motor, PMSM motor, and many more. In this presentation, we will discuss about BLDC motor. Let's start from a conventional DC motor first. It needs a brush to perform the rotation. It can cause brush lifetime dependent mechanical problems such as noisy and maintenance cost problem. Then, contrary, in the BLDC motor, there is no brush, but we need to know more complex method to control this motor. As I resume, it's a comparison table between DC motor and BLDC motor. It has much benefit using BLDC motor compared to DC motor. That's why now BLDC motor used widely, also in electrical vehicle. But we need more complex method to control this motor. And one of the famous basic method to rotate the BLDC motor is called with the 6-step. Okay, these 6 steps use 6 IGBT or MOSFET transistor to switch the winding on and off in a special sequence that enable motor rotation. This is the correlation between the stator winding, the step switching sequence, and Hall sensor signal. The rotor will rotate if the switching follow the proper sequence. This is the complete control sim that we will discuss today. How to build the simulation in the Simulink MATLAB. First, let's talk about Simulink MATLAB. Simulink is a MATLAB-based graphical programming environment for modeling. Using a block library or function, simulating and analyzing system using virtual scopes. It also can communicate and embed it into a microcontroller or digital signal processing hardware, such as Arduino. Let's see how to build the simulation. In this study, we use function block to include the 6-step algorithm. We can double-click the function block and write the code inside this. This is the Simulink-based design simulator for open-loop control. It performs to validate the 6-step function is running well or not. There are BLDC block, DC source, inverter block consists of 6 IGBT switching component and scope to show the simulation result. First, let's monitor the Hall signal and back EMF from these two scopes. Here is the result. Hall sequence look good. It follows the actual situation. Its signal lead or lag 120 degrees. And the back EMF simulation also give the proper result. Let's continue to the switching sequence. It can be monitored from this scope and From this graph, we can conclude that the switching sequence is properly follow the 6-step algorithm. And finally, here is the proof that motor can rotate. We can see from this scope. Here we can see the speed rotate in 3 seconds. It depends on the simulation time we give before. We can realize that the actual rotor speed is 10 times higher than speed command. That's why we need a speed control mechanism to regulate the speed. Next is closed loop speed control. Nowadays, we can find a lot of control methods, but in this study, we use the most powerful and applicable control method called PID. We need to add some Simulink library block to make it closed loop. The block are PID controller and a step function block that present the load, and make the feedback connection from output to the input. Then we run the simulation and check the result from the scope. Here is the result. The speed command present in magenta line and the rotor speed in blue color line. First, we simulate step speed. We can see the speed response is quite good. From the scope graph, we can conclude that PID can control the speed in the speed up and then the speed down, and can respond well to the load disturbances. Next, in this simulation, we also can find the current response. It can simulate how much electrical current occur to the system. Okay. From the result, it can be concluded that more speed, more current occur, and more load also more current occur. Besides speed and current, another response we need to know is about the torque. For that, we can check the torque response from this scope. From the simulation result, it can be concluded that more speed, more torque produced, and of course more load need more torque also. After our decision, we can conclude that BLDC motor speed control simulation has been successfully performed. And in this study, we use a 6-step commutation process on BLDC motor, which is implemented in the form of a commutation logic block function. Signal representing Hall response, back EMF signal, and IGBT switching sequence can be displayed clearly in the simulation. This is to validate that the commutation process is running correctly. And then the BLDC motor speed control system with the PID method was also successfully realized. It can be seen from the simulation result that the speed response signal, phase current response, and electromagnetic torque can be displayed. In the future, we have planned to do the hardware implementation and then another speed control simulation, and also performing another control method. Okay, thank you for today, and thank you for your kind attention. Assalamualaikum warahmatullahi wabarakatuh.